All right, hello students. So this is the worksheet for the lesson where we're solving with graphs and tables, and it's really crucial that you pay attention to how to create a table for each situation. And we actually have two different situations here where we're purchasing plants from a nursery. And when we look at this, the sentence right here, the first sentence that really tells us about any numbers is four tomato plants and two sunflower plants for $8. And I want you to think, what do we know and what do we not know? We know how many, but we don't know how much they cost. It is absolutely crucial that you define your variables. Get in the habit of writing down what your letters stand for. You're writing an equation. You better tell me what the letters stand for. So I'm going to say that X is the thing I don't know, the cost of a tomato, and Y is the cost of a sunflower. And then that sentence becomes an equation. 4x, because I bought 4 tomatoes, plus 2y equals 8. The other sentence, Persephone, notices that one sunflower plant costs the same as one tomato plus 1. Y is sunflower, x is tomato plus 1. I'm going to take each of those and create a table for them. We have one table about what Jalen noticed, and we have a different table about what Persephone noticed. For Jalen, all we know is that they must equal $8. So let's say that we bought zero, well, not zero, that the cost was zero, that tomatoes were free, and they bought two sunflower plants and spent $8. Then the sunflowers had to cost $4. If the tomatoes are free, then the sunflowers cost $4. If the tomatoes cost $1, then I've spent 4 times 1 on tomatoes. So I have $4 left to get up to $8. That would mean that each sunflower would cost $2. 4 tomatoes for $1, 2 sunflowers for $2 makes 8 total dollars. We know it's linear, so we can predict the next number, or you can run the numbers again. If tomatoes cost $2, 4 times 2 makes 8, and that means that the sunflowers must be free. Because of domain and range restrictions, I'm done with Jalen's table. Persephone notices something different. She notices that each sunflower costs the same as a tomato plus 1. So if a tomato is 0, plus 1 is the cost of a sunflower. If a tomato is 1 plus 1 is 2, is the cost of a sunflower. 2 plus 1 makes 3. And you should notice this is where the x and y values in each table are the same. That is the solution to the system. That's the combination of prices that works for both of the situations. What we're going to do is take that same information and use it to draw the graph. And so I have here 0, 4. So 1, 2, 3, 4. And then 1, 2 and 2, 0. And I'm not going to extend that line past the x and y axes because it doesn't make sense to have negative prices for tomatoes and sunflowers. And then for Persephone, she started with 0, 1, 1, 2. We already know that's the solution. And her line theoretically goes on forever because all she noticed is that the price of one is one more dollar than the other. And you can see the solution right there at 1, 2. Now, how do you check your work? You check your work the same way that we've always checked our solutions, by plugging it into the equation. Here we have two different equations to plug into, so we need to check it with both. I'll start with Jalen's equation. 4 times $1 for tomatoes, 2 times $2 for sunflowers. Does that make $8? Yep, 4 plus 4 makes 8. Check. Not done checking. We've only checked that 1, 2 is a solution to Jalen's equation. It's a system of equations that we care about, so we need to double check that it works. That 2 is equal to 1 plus 1 because I substituted into Persephone's equation 2 for y, 1 for x. I hope we all agree that 2 is equal to 1 plus 1, so we know that we found the solution to the system. Okay? It is absolutely crucial that you are able to make these tables and these graphs for this sort of a word problem situation. Okay, thank you for watching.